too many things to look at, too complex. So let's just look at these two, okay? Just zone 6 and zone 1, okay? These are two different zones. They have quite different properties. So zone 1 looks like this, zone 6 looks like this. And we were thinking back and we were like, okay, well, we saw loads and loads of under-frequency load shedding, okay? Under-frequency load shedding was the biggest cause of all of our kind of trips in the system. And that's going to depend on inertia. So let's create a case where we adjust the inertia of zone 1. So we're going to artificially lower it to exactly the same value as we have for zone 6. So we've made this kind of new comparison case where we've adjusted it. And because we were like, okay, well, there's all that under frequency load shedding. So my expectation is that this is going to have an effect and this is going to change my result. So then we run it, and this is what the results were before. And when we reduce the inertia, it doesn't really change the results at all. So we basically get the same kind of result. So the impact isn't that dependent on the inertia. So this is about as far as we've got. I don't have a nice summary that kind of explains what it is all caused by. We're still investigating it. But the point is, you get some clues, you think that it's under frequency related and therefore it's an inertia problem. So you adjust the inertia to try and see the impact that has. And then you do that. And then you still find out that it's all affected by loads of other things as well. So there's some outstanding questions that we have are things like, okay, is this actually a renewable problem? Or is this just a putting the generation in all in one place problem? Maybe it's a centralization of generation issue rather than it's a renewable problem. And that's something that we need to answer.
I have a question here. So for that, have you done this research that you did? Can you just go back to slide 85? Because you dropped the inertia of zone 1, right?
Yeah.
Have you done the other way around to increase the zone 6 inertia to the same as zone 1 and see if it changed?
No, we haven't yet. No, we have a whole list. It's a really good idea. We have that on the list of things to do. We have the kind of replacing with not with wind turbines. So yeah, replacing with synchronous generators, but locating those into the same place. We've got, unfortunately, as well, all these other axes that we need to investigate as well. So we're kind of working our way through it. It's not something that I would say we have bottomed out at this stage. It's very much this is a snapshot of where we're up to, where I think there's a lot of interesting challenges, and it shows that there's a lot of complexity in the problem and lots of things to look at. But it's not something that we've got to the bottom of yet.
The reason I'm asking that is because you have the renewable penetration increasing, right? So when it's increasing, then how your inertia has, your inertia will reduce, or your inertia will drop accordingly.
So we're displacing synchronous generators. So our loading in the system is staying the same. So when we add additional renewables,
you took one out, right? You took a synchronous generator out.
Yeah, kind of. So when we add more renewables, we'll run the security constrained OPF. It will dispatch wind first, provided it's secure to do so, and it will dispatch the wind before the more expensive fossil fuels. And then any fossil fuel plant that is essentially non-dispatched, we will disconnect from the system. So the addition of the renewables is decreasing the number of synchronous generators in the system, and so is reducing the inertia that way.
So if that's the case, then if you decrease that inertia down, it won't influence your high inertia situation because you're displacing that anyway. I suppose that this inertia is before you do the renewable penetration study, right?
Yes, exactly. Yeah. So this is the base case before all the wind turbines are added. Yeah.
Yeah, so my point is, if you are doing this high renewable penetration, then your inertia will be reduced to that amount anyway, because your synchronous generator will not be dispatched. So eventually, you're ending up as a 60, say 50% of penetration. Your inertia was low whatsoever, so you won't see the difference. But
Yeah,
this is offline. You can talk about it later on. I just want to know your setup, so I don't want to drag this too long. Sorry about that.
No. It's yeah, it's an interesting point. No, so we do. I know what you're saying. I think once we're down at the, sorry, I'm pointing at the screen that you can't see. When we're down at the low end of the stuff, we've still got some of that synchronous generation being dispatched though. So I get what you're saying, that at the higher levels, but I'm not sure we're high enough in terms of the dispatch to have essentially dispatched out that generation.